Mind-blowing space facts that will change the way you see the universe. Less than 160 kilometers above our heads begins a realm that defies comprehension. A boundless universe filled not with emptiness but with astonishing phenomena. Imagine stars inside stars, planets made of diamonds, black holes the size of atoms, and the theoretical possibility of white holes. Buckle up, Yuri. About to take a journey through the cosmos that will stretch your mind to its absolute limits. Earth is not perfectly round. We've all seen the photos. That beautiful blue marble floating in space. But here's the thing. Earth isn't a perfect sphere. And no flat earthers, it's not a pancake either. As the Earth spins, centrifugal force causes a slight bulge at the equator. This is due to the planet's mass being unevenly distributed, which drags out its middle. While the difference is only about 0.3%, that amounts to 41 kilometers, roughly twice the height of Mount Everest. Tiny yet enough to prove Earth is not the perfect ball we often imagine. The sun isn't burning. We often say the sun is burning, but that's chemically incorrect. Burning is a chemical reaction involving electrons. The sun, however, produces energy through nuclear fusion, smashing hydrogen atoms into helium under immense heat and pressure. It releases over 300 million tons of energy per minute. That's like detonating 100 billion tons of dynamite every second. In its core, the pressure is 250 million times Earth's atmospheric pressure, heating it to more than 16 million degrees Celsius. So no, the sun isn't on fire. It's a galactic pressure cooker beyond imagination. The heaviest object in the solar system despite being made of gases like hydrogen and helium. The sun holds 99.85% of the entire solar system's mass. Its core, only 2% of its volume, is so dense it's 15 times heavier than lead, accounting for half the sun's total mass, though it's only 109 times the diameter of Earth. It weighs a mind-bending 333,000 times more. It's like a feather compared to a freight train. Except the feather is us, the most massive star. If our sun got into a cosmic boxing match, it would be knocked out instantly by R136A1, a stellar heavyweight located 173,000 light-years away in the Tarantula Nebula. This star is 315 times more massive than our sun, equivalent to about 65 million Earths. R136A1 is a Wolf-Rayet star, containing massive amounts of ionized helium, carbon, and nitrogen. These ultra-heavy elements give it unimaginable mass and brightness, outshining our sun like the sun outshines the moon. The largest star ever found, while R136A1 wins in mass, UY Scuti dominates in size. If it replaced our sun, its outer edge would reach past Jupiter's orbit. With a radius 1,700 times that of the sun, its diameter exceeds 2.3 billion kilometers. Driving across it at 80 kilometers per hour would take over 3,300 years. Makes your daily commute seem pretty chill, right? The mystery of Planet 9 beyond Neptune lies the dark, frozen Kuiper Belt. Objects here behave oddly, as if being tugged by an invisible giant. Enter the hypothetical Planet 9. Scientists believe it has 10 times Earth's mass and orbits the sun at extreme distances, possibly taking 20,000 years for a single revolution. We haven't seen it yet, but its gravitational fingerprints suggest it may truly exist. How many stars are there? The Milky Way has between 100 and 400 billion stars. Now multiply that by 10 trillion galaxies in the observable universe. That's a 1 followed by 24 zeros. Counting 1 star per second would take you over 30 trillion years. That's more than 3 times the age of the universe. Good luck supernovas, cosmic explosions. Stars don't go quietly. Massive ones explode in supernovas, unleashing more energy in a moment than our sun does in its entire lifetime. One of the most famous, supernova 1987, exploded with such force that the debris took on a boaty shape instead of the expected sphere. Even death is dramatic in space. Black holes, giants, and miniatures when a massive star collapses. It can form a black hole, a gravity well so powerful not even light can escape. Take Ton 618, for example. It has a mass 66 billion times that of our sun and a diameter of over 390 million kilometers. But they don't have to be huge. Black holes can also be as small as an atom, yet still have the mass of a mountain. Think twice before messing with the universe. The mystery of white holes. White holes are the theoretical opposites of black holes. Instead of pulling everything in, they push everything out and let nothing enter. They've never been observed and violate some laws of physics. But neither did black holes. Until 1971. Maybe white holes are next. Diamond rain on gas giants on Jupiter, Saturn, Uranus, and Neptune. Lightning storms break down methane, forming carbon, which crystallizes into diamonds as it falls. Saturn might experience up to 1,100 tons of diamond rain every year. Now that's luxury weather. A planet made of diamond. Meet 55 Concrii, a super-Earth 8 times Earth's mass. Its high carbon content suggests that a third of the planet may be made of diamond. But don't pack your bags yet. The surface is over to 150 degrees Celsius, making it less of a paradise and more of a burning jewel of death. Saturn's hexagonal storm. At Saturn's North Pole swirls a hexagonal storm. First discovered by Voyager in 1988, it's 32,000 kilometers wide, with winds reaching 350 kilometers per hour. Why a hexagon? Simulations show it as the result of jet streams colliding at just the right angles. Nature, geometry at play. Auroras beyond Earth. Earth isn't the only place with stunning auroras. On Jupiter, they're so massive they dwarf our planet. On Saturn, ultraviolet imagery shows them glowing blue, though to the human eye they'd appear red and purple. Space, it turns out, knows how to put on a light show. Russian doll stars. Imagine a neutron star trapped inside a red supergiant, like a cosmic Russian doll. This could happen when a neutron star spirals into its partner during a binary system's evolution. Another theory, a supernova explosion could fling a neutron star into another, larger star. The result, a star inside a star. Creepy and awesome. A blue sunset on Mars. On Mars, the sky is orange during the day and blue at sunset, the opposite of Earth. That's because Martian dust scatters red light during the day. At dusk, the dust filters out the red, letting blue light pass through, creating a surreal scene that's nothing short of alien beauty. Sunsets on Venus and Mercury. Venus has a thick, toxic atmosphere full of carbon dioxide and sulfuric acid. Its sky glows a sickly yellow, and you can barely see the sun. Mercury, on the other hand, has almost no atmosphere, meaning its sky is black both day and night. It's like the moon. But closer to the furnace,